Hi all. I hope we are all well. This is a video about how to use the physics formulas. So I was noticing when we were doing our Google quizzes, sometimes we were finding it difficult with the tricky rearrangements. Okay, so once again, this is a video about rearranging physics formulas and then putting in the numbers and getting the correct answers. Okay, right, so here we go. Okay, so the first example we have is, and we're going to be solving a problem that looks at speed, distance, and time. So we have this question here: toy train travels for 45 seconds at a speed of 2 meters per second. Can you calculate the distance that it travels? Okay, so this was taken from a previous GCSE paper. Okay, it's 4 marks. Right, and I'm sure you've noticed already there is a diagram. So when I get these worded questions, I like to create a diagram because it just makes things a bit clearer for me. So I've got this train, this toy train, it's travelling or travelled for 2 meters per second, and it's travelled for 45 seconds, and we're after the distance. Okay, so the whole point of this video once again is about rearranging formula triangles. So here we go. Here is our formula triangle. Alright, so we've got speed, distance and time. And in this question we are after the distance, okay? We're after the distance. Yep. So if I'm after whatever you're after, you put your finger over it, okay? So, or your thumb in this case. I'm after distance, I've covered it up, okay? So it gives us speed times time. So that's our first step. We're going to write down that equation that we've rearranged using the formula triangle. So there you go, distance equals speed times time. Okay, just going to shift this up. The next step is to substitute in the numbers. So the speed is 2 meters per second and the time is 45 seconds. So that is what I have done just there. Okay. Right. Then the next step is to do the calculation on a calculator, and if you type it into your calculator, you should end up with 90. And the final mark, and the bit sometimes we miss out, is the inclusion of the units. Okay, so the units for distance are meters, so our final answer is 90 meters. Okay, I would say if you do put down 90 meters, you do get the full 4 marks, but by showing you're working, you're likely to pick up marks in case you've done a mistake in your calculation, like put the wrong number into your calculator. Okay, so moving on to the next physics equation that we're going to look at. Well, I'm not going to cover all of them, but I'm going to cover a couple, and then we're going to move on to the more advanced ones and more complicated ones. Okay, so here's another question from a past paper. Okay, different topic, same skill. So it's Newton's second law, or which I try and get that focus. I always think of as this thing F equals ma, which you can only see as an equation. But let's take it back a step. Okay, remember Newton's law is all about if you throw something hard or if you apply a bigger force, it should have a bigger acceleration. But we can calculate this. Okay, so in this example we've got a 0.25 kilogram glider. That's my attempt at drawing a glider, and it's pulled by a 1 Newton force. The question is asking us to calculate the acceleration of the glider. Okay, so once again we need our formula triangle in true Blue Peter style. Here's one I made earlier. Right, so we're after acceleration. Right, so I'm going to cover up acceleration. Acceleration equals our force divided by our mass. Right, so that's going to be my first step. Right, acceleration equals force divided by mass. Right, Okay, and I know it only says 1 mark this time, but if it was a full marker, like the previous question, we would have just got a mark. Okay, it's all about using that formula triangle. Okay, so next step is to put in the numbers, right? And so our force is 1 Newton, our mass is 0.25 kilograms, and if then we do the calculation, put it into your calculator, we end up with 4 meters per second squared, which is a unit of our acceleration. Okay, so just one more time, to get acceleration, I'm going to put my finger over it, okay, which acceleration equals force divided by mass. Those horizontal lines mean divide. Okay, if I'm after force, cover it with force, it's mass times acceleration. That line in the middle, that vertical line, means times in the equation triangle world. Okay, right, so those are the 2 main examples I wanted to show for students up to the level of grade 5. Okay, I'm now going to move on to more complex equations where there's more than 3 letters in them, 3 what we call variables or 3 factors. Okay, so Newton's second law, F equals ma, it's got 3 variables. Speed, distance and time, it's got 3 variables. We're going to move on to more complex ones now. So feel free to stop watching the video now. Thank you very much for watching. Okay, so the one I'm moving on to now is Gpa and Ke. Alright, just see if we can see that. So gravitational potential energy and kinetic energy. Alright, so what we have in this situation is a ball of mass half a kilogram, 0.5 kilogram, is lifted to a height of 1.8 metre by this gentleman here. What a brilliant drawing, Dan. Thanks, Dan. That's okay, Dan. And then it's dropped. Okay, so what it's asking us to calculate is the speed that it travels when it hits the ground. So this is a really quite a tricky question, and therefore it's definitely going to be around 4 marks, right? The first thing we have to do is, before we sort of get onto equations, is realising that assuming all the energy gets converted into Ke when it hits the ground, okay, our GPE stored is going to equal our kinetic energy at the end. So I've just written that down there. Okay, so the next thing we have to do is calculate how much gravitational potential energy we've got. Okay, so there's gravitational potential energy equation. As you can see, this one's got 1, 2, 3, 4 variables. So we've got gravitational potential energy, we've got the mass in kilograms, we've got gravitational field strength on Earth, it's about 10 newtons, so I'm going to use 10, and height. So I'm going to write out this equation. Okay, so shuffle up a bit. GPE equals M times G times H. Right, the next step is I'm going to substitute in the numbers. Right, so it equals 0.5 times our gravitational field strength, which we remember is 10, times the height, which is 1.8 meters. Okay, so now's the time to get out your calculator. So 1.8 times 10 is 18. Half of 18 is 9. So that gives us a GPE of 9 joules. Okay, of 9 joules, right? But remember, we said the GPE at the start is equal to the kinetic energy at the end. So this is what we're going to move on to now. We're going to look at using the formula for kinetic energy to work out the velocity. And this is where it becomes quite a bit trickier. All right? So here's my formula. So kinetic energy equals half times the mass times the velocity squared. So once again, that's my first starting point. I'm going to write out the equation. Right? So Ke equals half mv squared, where v, remember, is the final, going to be our final velocity. Okay? Right. So I want to get v squared on its own. So I'm going to cover up v squared. You're going to see it's Ke divided by a half times m. Okay, so it's I'm rearranging for the velocity. I want to get velocity on its own. So what I'm going to do is, right, that gives us v squared equals 2Ke divided by m. Right? And I've taken a little jump there because when we divide by a half, it's the same as timesing by 2. So we've got, so what I could have done is times the whole thing by 2. So times the whole thing by 2, we get 2 lots of K equals mv squared. Then I'm going to divide under by the mass. Okay? So at the moment I've got v squared. But this is the next tricky bit. I want to get v on its own. So I need to do the opposite of the squared. Okay? The opposite of the squared is, alright, is the square root. Okay? So v equals the square root of 2 times the total kinetic energy divided by the mass. Okay? So now we're at that point where we can just substitute in the values. Okay? So our velocity equals the square root of 2 times our kinetic energy, which was 9 joules. Okay, so 2 times 9, and then we're dividing it by our mass. And let's go back and remind ourselves what our mass is. Our mass is half a kilogram. Right, so it's 2 times 9 divided by 0.5. Okay, and we want to follow bid mass in there, but we want to do basically all of this first. Okay, so that is the same as square root of 18 divided by a half. Okay, how many halves in 18? Right, you can type that into your calculator, but dividing by a half, remember, is the same as timesing by 2. So that gives us v equals the square root of 36. Okay. Oh, I know what that is. I know my times tables. Okay, our velocity is therefore 6 meters per second. Okay, so I'm just going to go through the steps we did again. First step really was to realise that the amount of stored energy in that ball, gravitational potential energy, assuming there's no losses due to like friction as it falls, okay, the Gpa we started off with is going to be the Ke we ended up with. Right? And then our next step was to use the equation to calculate the amount of Gpa. So we substituted in the numbers and we ended up with 9 joules. Okay, the next step was to use the kinetic energy equation. Right? But we had to rearrange it. Okay, we had to rearrange it, and that's where we get our mark there. Okay, so K equals half mv squared, v squared equals 2 times K divided by m. So we times over by the 2 divided by the m, or we said, well, we're after v squared, it's K divided by half times m. Okay, then we've got v squared, so we can find v by square rooting both sides. That leads us to velocity, putting in the numbers essentially. Okay, so it's 2 times our kinetic energy from before, which is 9, divided by a half, which gives us 18 divided by a half, which gives us, or square root, sorry, of 18 divided by a half, which is the square root of 36. Beautiful number, 6 meters per second squared. And breathe. Okay, so that is the video. Thank you very much for for watching. Any questions, just let me know. Okay, take care all. Bye bye.